Hello, am I audible to you guys? Okay. Is my screen visible? Okay. So, good evening, everyone. Today, we are going to learn something really important for people who work with software systems, websites, or apps. Something that helps keep system healthy and run 24/7. Okay. So, the topic is log event monitoring logic, and we will talk about three key parts, that is error rate, traffic spike, health alert. Before going to these three part, let us know some what actual this means. So whenever you open an app or a website, thousands of small events happen in the background, like user clicks, database call, and file loads or network request. So each of these events get recorded in a small digital notebook called a log file. So these log files help engineers see exactly what the system is doing, and if anything goes wrong, log help us to find the reason. But in the modern system, millions of events happen every second, right? So we can't read all the log manual. That's why we built log monitoring system. It is an automated tool that continuously watch the log, detect you unusual things, and send alert if something goes wrong or something is not wrong. So, in short, logs are like the heartbeat of a system. Monitoring is like the doctor checking the heartbeat, and alert are like the warning signs before a heart attack. So, by the end of this class, you will understand how big tech companies like Google, Amazon, or Netflix keep their app running smoothly using this kind of logic. Okay, so let's go to the next part. Yeah. So, why we monitor logs? Let us understand the importance of monitoring logs. Imagine your favorite app, like Instagram. Millions of users upload photos, send messages, and watch videos. Behind the scene, thousands of servers are handling all the traffic. If one of them stop working, it can affect millions of users, right? So, how does engineering team know what's going wrong, where and when? Any idea? Yes, am I audible to you guys? Okay, so the question is, how does Instagram engineering team know what's going wrong, where and when? It's through logs, right? So logs record every important thing happening in the system, like user login, database error, network request, CPU load, and so on. Monitoring these logs gives engineering a complete picture of system health. Okay, if something unusual start happening, like too many failed logins or sudden traffic increase, or monitoring tools immediately send alerts. That's how we move from reactive mode, like fixing problems after they happen, to proactive mode, detecting and preventing problems before users see them. Okay, so let me ask you, when you are using an app and it suddenly stop working or shows an error, what do you do? Guys, I will mark present those who answer. Okay, I'm asking you again. When you are using an app and it suddenly stop working or shows an error, what do you do? Check for updates. Okay. Basic thing. What do you do? Restart that. Okay. Yeah, right. Reboot. Okay. You go back and come again. Okay. So that's right. You either refresh it, you either close it, or you file a complaint. So now imagine if the company already knew that the issue like the is going to happen and fix it before you even notice it, right? So that's what good monitoring does. Okay, let's go to the next part. So four golden signal. Okay, so now let's talk about something that every good monitoring system is based on. The four golden signal frameworks developed by Google site Google Site Reliability Engineers. So it focuses on four key system health indicators. First is latency. Can anyone tell me what is latency? Anyone who know what is latency? Okay, so latency is how fast the system responds to a request. Example, when you click on a link, how long it does it take to load? If it takes too long, yeah, right.
And
Yeah,
latency is exactly measured how many responses or how many data packets transferred for millions of seconds.
yeah. So when you click on a link, how long does it take to load, right? So it's an example. So if it takes too long to load, user feels the system is very slow. The next point from the four key are traffic. So the number of requests or user hitting the system per second is known as traffic. It's like how many customers are entering a shopping mall every minute. Next is error. Can anyone tell me what is error? Anyone? Issue or problem. Okay. So the number or rate of failed request, right, is known as error. For example, if your app shows server down or 404 not found, that's an error. Okay. And the fourth and last rule is saturation. Anyone who knows what is saturation? So that means how full your system resources are, like CPU, memory, storage, bandwidth. Okay, so if a system is 100% full, it cannot handle new requests. So if you monitor these four signals properly, we can easily detect those issues earlier. Okay, so in this session, we will focus mainly on three, that is error rate, traffic spikes, and health alerts, which are closely related to each other. So, you can write these four terms on any notepad if you want, or I will provide you a note. That is latency, traffic, error, and saturation. These are common questions could be asked in an interview or uh, in any PPT presentation. Okay, so let's go to the next part. Okay, so let's start with error rates. One of the most important indicator of system health is error rate. So what is an error rate? It's simply the percentage of failed request out of total request. For an example, if thousands user try to open your website and 10 get an error, then your error rate is 10 divided by 1000 into 100, that is 1%. A small error rate is okay. Every system has small hiccups, right? So, but if it suddenly jumps to 10% or more, it means something serious is wrong. Also, this could happen due to a new bug introducing the code, database collection failure, network outage, or dependency service failure. Okay, so the value of monitoring error rates is that it helps us find issues before they spread. Can anyone give me a real life example on this particular thing?
Ma'am, regularly when multiple users want to check the result at the time of result declaration,
Right?
it shows 404 404 error, or sometimes it shows system the site crash. This kind of thing is
Mhm.
happening because
Right.
multiple users are trying to access the same. That's why this kind of thing is happening.
Yeah. So it's due to traffic, right? So explaining this small thing, let me give you an example of, just a situation. Okay, think of a hospital. If one patient come with fever, it's okay and normal. But if 50 patient comes with the same fever in 1 hour, that's a red alert, right? So something is spreading fast. Similarly, error rate tell us when our system is catching a digital fever. I will go at the last of this class. I will show you a demo, like how the things happen, how we can measure the error rate, how to write it, and all. So, what kind of error do you think a website might log other than 404? Anyone? Let me repeat again. What kind of errors do you think a website might log?
Ma'am, 500 error
Mhm.
and 300.
What is 500 error?
500 error is the client side request error.
Or is it an internal server error?
Oh, okay.
Okay, yeah. So you can see for client error, it is 404, 403, or 400. Okay. For server error, it is 500, 502, and 503. And authentication error is 401, unauthorized. Yeah, right. Uh, it may show database connection failed, like these kind of errors, like login failed, page not found, payment didn't go through, server is down. These kind of errors we will see in a website. Okay. So till here, anyone like having doubt till here? No, yes, anything? Any doubts till here?
No, ma'am.
Okay. So let's go to the next part. Next, let's talk about traffic spikes. So another major reason system crash is because of traffic. Traffic means how many requests or users are visiting your system per second. Normally, traffic is steady, but sometimes it can suddenly increase due to different things. Let's talk about a new product launch, a viral post, a big sale, suddenly releasing the marks, or a DOS attack. Can anyone tell me what is DOS attack? Okay, see,
Ma'am,
basically,
DOS attack stands for denial of service attack,
yeah.
which, in which I'm unable to get it. Can please describe that?
Okay, it's okay. So, denial of service attack is basically happens to, we can say the client side. Okay, like a client want to access something. Okay, but it can't access because of this particular. These are the malicious attacks. Okay, so it is one type of most serious type of issues. We can say Attack happens when someone tries to make a website or a server unavailable by sending too many requests at once. For an example, Smriti, yeah. So if you, Smriti, have made a website and I am a hacker or I am a person who doesn't want that website to work for the other users, what I will do, I will send multiple requests at once. So because of that, the traffic get jammed, like traffic jam happens, and the actual users would not be able to use it. Okay, am I clear?
Yes, ma'am.
Okay, so yeah. So after DOS attack, for example, if a shopping site usually handles 1,000 requests per second and suddenly it gets 3,000 requests per second, that's a 300% spike. So when the traffic spikes, the system resources like CPU, memory, bandwidth get overloaded. And if not managed, this can cause latency, that is slow response, and errors, that is system crash. That's why company use auto scaling. That will automatically add more servers when the traffic increase, and log monitorings. Okay, to detect spike in real time. Um, let's think about, imagine a restaurant. Okay, that serves around 50 people at a time. Suddenly 200 people walk in. If there are not enough chef or seats, customer get angry, right? So that's exactly what happened to a web server during traffic spikes. Let me ask you one more question. What do you think engineers can do to handle traffic spikes efficiently?
Network engineers, ma'am.
Sorry?
Network engineer.
Yeah, what they can do to handle these things? Okay. So they can do load balancing, they can do caching, they can use rate limiting. Right. Till here, any doubt? Okay. So let's talk about uh, health alerts. It is the superhero of monitoring. So health alerts are automatic notifications that tell engineers something is wrong, even before user complains. Okay, so they work on threshold. For example, if error rate is greater than 2%, send alert. If CPU usage is greater than 85%, send alert. If latency is greater than 2 seconds, then it will send alert. So these alerts go to the engineer through tools like Slack, email, or pager duty. Okay, yeah, load balancing again. So the idea is simple. Take action fast before the system fails. But here, something important, like too many alert causes alert fatigue. People start ignoring them. Okay, so alert must be well designed and meaningful. Okay, so let's talk about analogy of analogy. So the health alerts are like your car's dashboard lights. When oil level is low or engine is too hot, it shows a red signal or sign, right? So if you ignore it, your car breaks down. Same thing happen in the system. More as as you send a lot of alerts at a time, people might ignore them. Okay, so well designed and meaningful alerts are required. Let's go to the next part. Okay. So here it's let's look at the real world situation. Imagine a shopping site during a flash sale event. So at 12 p.m. the sale starts, and within minutes traffic shoots from 1,000 users to 3,000 requests per second. So server get overloaded, database can't keep up, and CPU usage jump to 95%. Within seconds, the error rate reached to 15%, and users start seeing 503 service not available or service unavailable. So now because of log event monitoring, the system had alert set up. So CPU above 85, error rate above 2%, traffic above 2000 RPS. So within 2 minutes, the alerts were triggered. So engineers immediately scale up the system, add more servers, and within minutes, everything is back to normal. Without monitoring, they would lost thousands of customers and sales. Right. So this example shows how important is it to detect and react fast. Logs and alerts make that possible. Okay. Let me show you an example. Just a second, guys. Oh, yeah. Is it visible?
Yes, sir.
Just a second. Okay. So this Python script stimulates a live monitoring system that checks error rate, like the percentage of failed request, traffic, how many users or requests per second is happening, CPU usage, that how busy the system. So it continuously print these values and show alert when something abnormal happens, just like real monitoring tools. So this is just this is a stimulate. Okay. So first, let's check about just a second. Yeah. So here you can see the first thing, that is import random. Can anyone tell me why import random is used over here?
For generating random values.
Yeah. So to generate, say, random or values or data. Okay. And import time is to create delay between each reading. Okay. Yeah, right. It takes random numbers. Like, the time, report time is to create delay between readings, each readings, like real-time updates. Okay. Then is def monitor underscore logs. So this defines a function named monitor underscore logs. All your monitoring logic will run inside this particular function. Then we are going to use infinite tool over here. So because we don't know, any condition over here, so the code will keep running continuously, checking the system data again and again every few seconds, just like real time monitoring. Then let's talk about error rate, traffic, and CPU usage. So here I have written error rate equals to random dot uniform 0, 10. Can anyone tell me what is random dot uniform? Why is it written random dot uniform? Any idea, guys? What is random dot?
Give numbers between 0 to 10.
Okay. So it is used, which gives decimal float numbers. Okay. So we are pretending that this number is the error rate percentage in our system. Like these numbers, like 3.5 means if error rate is 3.5, it means 3.5 percentage of all the failed requests. Okay. So a uniform means any number between 0 to 10 is equally possible. We use it here because error rate can be any decimal values, not just whole numbers. Right. Any doubt about random dot uniform? Okay. So then what is random in it? What is random? Yeah, right. Random integer. Okay. So basically, when we talk about error rate, it generates a floating point number between 0 and 10, like 5.67%. Traffic, it generates an integer between 50 and 600, because we can't, like, I don't have a website over here, so I could show you how it was managed. This is just a simulation. Okay. CPU usage, it generates an integer between 20 and 100%. So these value act as if you are reading the real time real system address. Okay, then print, error rate and all, what you want to print over there. So you need to print over there. This print the live value of a in a single line, like error underscore rate means show the number up to 2 decimal places. Like 2F means 2 decimal places. Okay. So now comes the monitoring logic. So if error rate is greater than 5, print alert, high error rate detected. Okay. So this means if error rate is greater than 5%, print a warning message. So too many requests are failing. Possible is bug or server issue. Next, similar for traffic, it will show 400. Uh, like traffic spike if it exists, 400 requests per second. Then for CPU, if the usage cross 85%, it will show a health alert. Then print dash dash into 50, because I want to separate them. Like, it helps separate each log reading visually in the terminal. That's the reason I have used that. Then pause the uh, this pause, you can say the program for 2 seconds before repeating the loop again and again. It stimulates real-time update that comes every few seconds. Okay. Log underscore monitoring is finally you call the function so that it actually start running. Without this line, uh, nothing would happen. Okay, so let's run this particular code. Just a minute. Okay. See, so first error rate is 2.86, then traffic is 72, so no alerts. Then again, it gave alert because traffic was high, so traffic spike. Then error rate was high and traffic was very low, CPU was very low, so error rate detected, right? Over here, you can see error rate and traffic rate and CPU is three-way in the high. So high error rate detected, traffic spikes, and system health. So it will give us similar. These will log it, right? Okay. So any doubt in this particular code? Okay. So let's talk about the best practices then. Okay, so when we talk about the best practices, so track rates are not just raw numbers. So, 100 errors out of 1,000 requests means 10%, which is worse than the 100 out of 10,000. That is 0.1%. So use percentile matrix. These shows slowest request that user face, not just the average. Okay. That dynamic threshold, that is what's normal in one month may not be normal in another, like sale traffic, or uh, suddenly your college or your university announce your marks, and it's there is a huge traffic in the website, so use a dynamic threshold. Combine log, matrix, and traces. So logs tell what happened, matrix show how bad it is, and traces tell where it happened. Okay. Then avoid alert fatigue. That is, don't alert on everything, only on meaningful issues. Next, let's talk about tools and technology. Just a second. So when we talk about tools and technology, some professional tools which are used for log monitoring are Grafana. Okay, Datadog. Like Grafana is open source, free, and very popular. Datadog are commercial tools. Elasticsearch and Kibana or ELK Stack. Then AWS CloudWatch. So these are used for cloud systems, log visualization, and all. So these tools use AI and machine learning to automatically detect, uh, you know, anomalies, or so that the system can even tell you what when something feels wrong. Okay, so let's talk about the conclusion. So to sum up everything we learned today, logs are the eyes and ears of a system. Monitoring help us to detect the issue earlier. Error rate, traffic spike, and health alerts are three pillars of system health. And using frameworks like four golden signals, we can build reliable, scalable, and fast system. Okay, so remember, engineers who monitor well sleep well. Okay, so because the system take cares of them, themselves. So yeah, so till here, any doubts? Any question? Oh wow, no doubts, no question. Okay, so let me give you a task. That is, you need to make your own stimulation where I want modifications such as memory usage, timestamp, and stop the program after 10 minutes. Okay, so let me write it down for you guys. Okay, so these are the question. If any doubt, just ask me. Okay. So guys, any doubt till here? Like you need to modify your stimulation by adding memory usage, timestamp to each reading, and stop the program after 10 readings. Okay. So will you do it now, or will you know, uh, do it as a homework? Hello, am I audible to you?
Yes, ma'am. Yes, ma'am.
So will you guys do it right now, or should we do a Q&A session and end the session? Guys, you feel free to do anything. There is no problem. Okay, so let's do a Q&A session. I will ask you some questions, and according to that, I will, give you marks. Okay. So the first question is, what are logs in a computer system? For answering, you can raise your hand, and then I'll ask. Let me repeat. What are logs in a computer system?
Timestamp records of events, activities, and messages.
Yeah, right. So logs are records of events or activity happening inside a system, like user action, errors, or server messages. So they help engineers understand what the system is doing. Okay. Chronicle reports of events or activities that occurs within software, hardware, or network components. Yeah, right. Then, why do we monitor logs?
Ma'am,
Yeah.
to check the reliability, scalability, and functionality of a application in a real-time use industry and a real-time use platform, we refers to the log file. That's why we use that.
Right. So to detect problems early, reduce downtime, improve performance, and keep system running smoothly. Okay, that's the reason we use or we monitor the logs. Important events. So, what is an error rate? With example, these are the Again, let me repeat. What is error rate?
Waiting of a process or a
Uh, Not particularly. So it's the percentage of
Madam,
yeah.
error means there's a request and this field and not recorded by mistake.
Okay, so it's the percentage of failed request compared to the total number of requests. In simple words, percentage of failed request compared to the total number of requests. Okay, that's it. So example, we can take 5 errors out of 100 requests. So 5% is the error rate. Then, what are the 4 golden signals used in system monitoring? Traffic, error, latency, saturation. Right. So latency, traffic, error, and saturation. What does saturation mean in monitoring? What does saturation mean in monitoring?
indicates how close it is to reaching its capacity limits.
Yeah, right. So it shows how full or busy system resources are, like CPU, memory, or disk. If they are 100% full, then the system can't handle more work. The system is overloaded and struggling to handle additional, right? So why are alert important? Let me repeat again. Why are alerts important? Avoid overload errors. Okay, reduce downtime and security. So alert informs engineers before user face issue. So they help teams to act quickly and prevent the system failure. Okay. So what causes a high error rate? Let me repeat again. Human error. Hmm, Not actually. Okay, bugs in code, database failure, network problems, or too much load on the server. Okay, let me ask you. What does random.rand in 50,600 represent in the code? Everyone kindly check the chat box. So I have written random.rand in 50,600. What does that represent?
It can give the value between 5 to 600. Oh, sorry, 50 to 600. I'm sorry.
Yeah, so random integer between 50 to 600. So guys have, I guess you have noticed or not, I don't know, but we have used over here while true. So somebody was asking to show me do while program, right? Or do while, do the do while program in Python. But we know that there is no do while program in the Python. Other than that, we for similar kind of effect we use while true. So it creates an infinity loop. So the monitoring continues without stopping, like real time log monitoring. Okay. So that was just a fact. The next question is time dot sleep 2 or time dot sleep 4. What does that mean?
Sleep for 2 minutes, 2 seconds.
No, so it pauses the program for 2 seconds before checking again. Yeah, pauses the execution for 2 seconds, right? So you guys have any doubt or shall we wrap it up? Any doubt, guys?
No, madam.
Okay, then let's wrap it up. Okay, so thank you everyone for listening. I hope you know understand how log monitoring helps keep the real world data running smooth. Okay, So you will,
Thank you, madam.
guys, you will